Welcome to Tech Talks. Our security edition today is focused on hunting for malicious PowerShell using script block logging. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customer, and want you to continue in your Splunk journey. Our experts help create these best practices, and we want you to leverage them in your daily role. I am Michael Haig, Senior Threat Researcher, and I'm excited to share with you information about our PowerShell logging. Today's agenda will cover what is PowerShell Script Block Logging and how Splunk can help. We'll discuss how to enable logging and generate atomic data. And then we'll jump into a demo, find suspicious keywords, and use our analytics that we created. And then we'll cover additional resources available to help you take advantage of focus area capabilities in Splunk. If you have questions, please continue the conversation through the Tech Talk discussions in the Splunk community at splunk.com/Tech Talk. So what is PowerShell Script Block Logging? PowerShell Script Block Logging is the raw, deobfuscated script supplied through the command line or wrapped in a function, script, workflow, or similar. Think of every time an adversary executes an encoded PowerShell script or command, script block logging provides that data in its raw form. On the right-hand side of the screen, you can see a log or a script that was executed on my endpoint in the background, more or less. Whether it was encoded or not, script block logging will deobfuscate that and we'll receive the raw log, the raw script. And at the bottom, there's actually the path of the script that was executed. So you're even able to find where this came from by just looking at a script block log. Why is it important? PowerShell logging is 3 more sources on the blue team tool belt to help detect suspicious and malicious activity. In particular, PowerShell to this day is still used by adversaries of all skill levels. It's easy to go and copy and paste something from the web or use old toolkits from 2015 and 2016. PowerShell is still native on all Microsoft OSs that are still being mostly used today. It's also required utility for accessing certain applications or features, for instance, Office 365 or Azure Active Directory. PowerShell is still used all the time. So it's important to know and understand that we have many logging capabilities, and as a blue teamer, the ability to hunt through these logs effectively. Show me the data. This particular script we had written just for gathering PowerShell audit logging. It's called invoke SPL PowerShell audit logging, and it's located at this repository. It's under my notes and utilities. This script will help with enabling one or all script block logging for PowerShell. So it'll do script block, module, and transcript. And we also enabled a couple other features in here that assist with gathering those logs. So it will actually create a conf file for you to gather the transaction and just standard script block logging. This script is actually an expansion upon a script that Hurricanes Labs wrote. So we took it and we just expanded upon it to make it even better. So in this instance, this is a screen cap of what it is to use invoke SPL PowerShell audit logging to create a conf file. So it actually will create all the inputs, creates an app under the Splunk Universal Forwarder, SPL audit logging, and then it writes the local file and the inputs.conf. It will then restart the universal forwarder so that everything gets set up. And inside that new inputs.conf is, the right monitors for PowerShell script block logging within the PowerShell operational log, and then also transaction logs, which is a defined path where you want to place those logs, which we discuss in our demo. So what data to get or not? Again, we can enable all logging. So it just gathers everything, transcript, module, script block, and I even added 4688 with command line. It can also just create the inputs. Depending on what you need, you can enable with this. The feature that I love the most is just enable all logging. So it just gathers everything that I want. In addition, when you're all done, say in a lab environment, you can just disable logging and start over or move things around however you like. Also, in a more enterprise type environment, you might want to enable these through group policy. And that's located under computer config, policies, admin templates, Windows components, and Windows PowerShell. You can enable all PowerShell audit logging through group policy. We discussed this in our demo by creating a separate policy object. And so that we can just modify it and apply it to critical assets or assets I only want to gather PowerShell audit logging from. In addition, if maybe you want to use a logon script, you can also modify all of these through the registry and invoke SPL audit logging. SPL PowerShell audit logging has all of those registry modifications already written in PowerShell. So it's easy to copy and paste from there. And we also go into this in detail in our demo, where we will show in the registry what this looks like before and after modification. Atomic testing. The idea here is that we want to produce good telemetry trails using some data, whether it's doing it through Atomic Red Team. And so in this instance, we'll start using it with invoke Atomic Red Team. This is fairly easy to use. Within the wiki page, you can gather the quick command to copy and paste into your PowerShell session and kick off the installation of invoke Atomic and the Atomic Red Team repository. In this instance, there's two MITRE techniques that I recommend using to generate data so that you can start using our analytics with. That's T1059001, which is PowerShell, and T1482, which is like domain discovery. So both of those will generate some solid information. In addition with that, if you want to provide some more like real world behavior, I recommend checking out Empire, PowerShell Empire through BC Security and or Cobalt Strike. Both of those provide a very simple PowerShell harness that you can execute that is encoded PowerShell and performs other activity on the back end that you're able to capture with script block logging. Tips, just think about initial access. How will you deliver the HTA in particular? Say you want to just put it on Dropbox and then you could download it through Dropbox. You could send it in through email, click the email, whatever it is. Mostly just here to help generate that trace data, that telemetry trails, so that you're able to capture that within your environment for additional analysis, even beyond just 4104 script block logging. So now, for our demo, we're going to walk through how to enable logging, simulate, and then review it inside of Splunk. Welcome to our demo. First, we're going to showcase how to log PowerShell 4104 events and transaction and module logging. From there, we're going to generate test data using Atomic Red Team. And then we're going to go into Splunk and begin to hunt through 4104 script block logging. So to begin, I want to showcase the three methods that I mentioned in our slides. First is through group policy. In my environment, I am a server 2016, and I opened up group policy management, and I created a new object called PowerShell logging. And this will be your more enterprise way of gathering these logs across your whole fleet or part of your fleet. In this particular instance, I'm just adding it to the full domain, and I already created an object called PowerShell logging. Within that, to get to PowerShell logging, it's under Computer Configuration, Policies, Administrative Templates, Windows Components, and Windows PowerShell. In here, you'll see each option that you're able to select and enable whichever ones that you would like to have across one or many endpoints in your environment. In this particular case, we're focused just on PowerShell Script Block Logging. So you can double click it, enable that, begin to log this. Quick note, this does post to a Windows event log, which is the Windows PowerShell operational log. You want to make sure you're capturing that across those endpoints in particular. So that's one way. The next way is manually through the registry. So if you're looking to kick this off through maybe like a logon script, or you already have something set up today that you can just enable this through, modifying the registry. This case, it's under HKey local machine, software, While6432 node, policies, Microsoft, Windows, PowerShell. And you can notice that here in the tree, it's a little nested. And in this particular instance, I already have module logging, script block logging, and transcription already enabled in my environment. So you can see what the final output looks like. And then our third method is a script that we've written and we're releasing. It's invoke SPL PowerShell audit logging. This script was written around another script that was published by Hurricane Labs. All we've done is we've adopted it and we've added abilities to use different parameters and select what you want to begin logging versus just enabling everything. Maybe you only want script block logging or module. You can enable one or the other, or just enable everything. We've also built in the ability to disable all the logging and also process creation, which is 4688 with command line added. In addition to it, I added a way for it to create the inputs for all of these logs. So it will automatically grab that script block logging, 4104 type events. It will also grab the transaction logs, and all of these are set as parameters. So if you have a different path for your universal forwarder on your endpoint, you can pass that as a new parameter, telling it the path to where to install the app. And you can tell it where to grab the transaction logs if you want to place them in a separate directory. I will demo that right now, just so you have a good idea of what this looks like. So first, I'm just going to import the script. And this might be really good for lab environments, or you want to test out what these logs look like. First, I'm just going to get the help of invoke SPL PowerShell audit logging. And this gives you the high level view of what the script can do. So for instance, I mentioned there's the multiple methods to enable all or one or the other. If you want to see examples, you can pass examples here. And I have 4 examples built in. So if you really want to just copy and paste, you can just copy and paste this into the prompt and you can enable whatever you would like from there. In my instance, I'm going to just copy this one. I want to enable all logging in my environment, and that's the method I'll pass. And that will go and kick off script block, module, transcription, and everything else. So from there, I'm going to, so because I had transactions already enabled, the directory was already there. So now I want to also create the inputs because I need to begin capturing this in Splunk. So I'll do method create inputs and I'll kick that off. It will go and create the SPL audit logging folder under my universal folder, universal forwarder, Etsy apps, new directory. It creates an inputs under the local, and then it will paste in the actual pieces that we need for capturing these logs. And I'll show you that here in our script. So by default, this is what it will capture. It puts it under the correct source for you in the index. The index is hard-coded, so if you want to change the index, you'll have to manually do that. Otherwise, it's not a big deal. So that's how to gather all the logs using group policy, the registry, or invoke SPL PowerShell audit logging. So from there, we need to generate some telemetry so that we can begin to hunt through this data. I'm going to start with invoke atomic red team. Invoke atomic red team is an execution harness written in PowerShell that will run atomic red team test. In this instance, if you haven't used atomic red team before or invoke, you can quickly get started by going to the wiki at the top here, clicking installation, and easily running this command that will install the execution harness and the atomic red team folders. It will gather everything for you and you're ready to go. Now, for instance, I'm going to first begin with running invoke atomic test T1059001. This is PowerShell. First, I'm going to run get prereqs. This will gather any prerequisites that the tests require, and maybe that includes any files or anything from sysinternals, or even requisites for Mimikatz, things like that. Now that that's done, I'm going to run show details brief to understand all the tests that this will be running. And so in our case, there's 20 tests in total. Now I'm going to just run T1059001. As this is running in the background, there's two other tests I'm going to run at the same time. I have two HTAs, which are HTML applications. One is from Cobalt Strike, the other is from PowerShell Empire. And both of these are just simply PowerShell commands that execute that connect to a remote command and control server that I manage. So easily enough, let me just close this atomic test. I'm going to go to my desktop and run my invoice. And then I'll run my next or my welcome to. And that's that. So that's all here to just generate additional telemetry trails. Not too worried about these errors. These are all just a file that is unable to be written to because it's also being used by another process. I'm going to let that continue in the background. Now it's time to go into Splunk and validate our data showing up and see what else we can do with this data. Initially, I began with mostly running just simple keywords. I was looking for Mimikatz, and in this case with Script Block Logging, I can see everything that was executed. And if it was encoded, the way Script Block Logging works is it's the decoded command that's captured and put into logs. And that's why we're able to see everything here in the background with 4104 type events. What about base 64? Anytime base 64 is used in that command line or within script block, you're able to capture that here as well. So you'll start to see all these very large scripts that are using base 64 encoded commands, or it has from base 64 or to base 64, depending on what it is that's running. Well, this led me down a road of creating a query, an analytic that uses Splunk's eval feature to eval 4104 events looking for keywords. And I started writing it very simply, just looking for from base 64 or matching on the name Mimikatz. Think of these almost as like regex patterns. You can use regex with eval, but think of them all like as a regex method to go and query this data. Just looking for certain things. At the beginning, I just started scoring them all as a score of 1. So if it matched, it would just score 1. So if one particular script had 10 things, the score would be 10. Well, over time, as I started playing with this, I realized there's certain ones that are more high fidelity than others, and I wanted those to trickle more to the top. So I started adding scores from 0 to 5. If it matches, it's a 5 on this particular one, which is looking for download file or download string. Bits transfer, that's probably going to be more high fidelity compared to other ones where it's not so important, like invoke expression. We might see a lot of administrators or different scripts running IEX, and that's fine. We just, we want to know about it, but we also want to score it with other things within our keywords to make that trickle more to the top, or maybe it's just something that's not so high fidelity and it's at the bottom. Now, my keywords was more or less the beginning of just my quick research. Alex on Twitter, inode E on Twitter, he had also been doing a lot of the same work. And so he released his, what he calls Splunk hyperqueries to score and rate suspicious PowerShell execution or activity on an endpoint as well. Very similar patterns. He's using eval and he's matching it against different patterns and whatnot that he can capture out of 4104 or PowerShell, within Sysmon event ID 1. And what I ended up doing was there were some that he had that I felt were really good. So I gathered those and I added them to mine because mine again was more for hunting, not so much for scoring and generating like a risk dashboard or anything like that. I really just wanted to hunt through this data because it's very voluminous and I want to know what's going on. So the final product ending up being this particular analytic. It's my hunting analytic for PowerShell. So every piece in here either will trigger or it will, capture a portion of some of these PowerShell scripts that execute. Now remember, we had also executed 2 HTA files that are pretty suspicious looking. So I always try to remind folks that when you're simulating, try to simulate it and make it look like it's something that's happening in a real world environment. So that might be, hey, if we're going to deliver this, let's deliver it through either an email or deliver it through like Dropbox. Here's a link, please click and open it. Those are very easy ways to perform delivery. I'm running this for 7 days because I have a lot of data in my environment for the past week. I'm going to sort it, and you can see my dashboard fills up really well, or the table here at the bottom. I have a lot of really interesting data, and my scores on the right reflect it, right? So I see that this one has base 64, it matches on my Empire eval that I have, invoke expression, encoded command. This one's pretty high fidelity. Like, this is definitely a match of something very bad happening in my environment. I can go ahead and click on that score and view these events. Takes me to the next tab here, and now I'm able to drill in and see that exact script. Now when you're looking at this, I always think about it, well, are there any other keywords that I might be able to match on next time? Can I modify my hunt analytic to even dig deeper? So maybe there's a new keyword that's being used, or there's something else in this script that I don't have coverage for. A good example, just looking at this, maybe it's data length or this join right here. Maybe that's not so common. And that would be a good way to modify our analytic by adding a join eval and then just adding that maybe as a low score, just something of interest for next time. But maybe over time, as we see more malicious and suspicious PowerShell, that join begins to show up more, and then we can make it more high fidelity. As an analyst as well, you might not want to see the high scores, but let's flip this and look at the inverse and look at these low scores. Maybe there's something in here that might need to be trickled more up to the top next time. And you can drill into each of these just like we did on the last one and see what else is happening. I want to highlight one high fidelity one over here, and that's this do it one. Do it is a function within Cobalt Strike's encoded PowerShell. So when I ran that Cobalt Strike HTA, it has a very common pattern of using the function $do it. So if you look at this one, you'll see that this is the do it function that is very commonly used with Cobalt Strike. And then you can see there might be other items in here that we could tee off next time. All right, so that is quite a bit of information. Let's talk a little bit about more of what Hurricane Labs produced on top of their research into PowerShell logging as well. They did release a TA for PowerShell transcript logging. Within it, it comes with all the field extractions and just different event types and whatnot, and it's a really, really good TA. If you're just getting started in logging PowerShell, this is a great place to start. They also have a very powerful blog that they released with it that talks about logging PowerShell data and then also going through it as well. This is from last year, so it's still very fresh, and everything in here will get you started with your PowerShell logging. So with that, during our demo, we covered how to enable PowerShell logging through group policy, registry, and invoke SPL PowerShell audit logging. We then performed atomic tests to generate telemetry in Splunk. We then focused on digging through Splunk using our new analytic that we created to match on keywords of interest within PowerShell script block data. All right. As we reviewed in our demo, we walked through how to log, how to capture it, and then how to review it in Splunk. With that, I want to talk about hunting with 4104 a little bit more. In our demo, we talked about using this analytic that you see on your right-hand side of the screen. We created a macro just for this. And so if you need to, you can modify this macro to your environment, but the macro itself looks in the PowerShell operational log. So it's very simple to use and see. And then this analytic was the final one that I pushed out to our repo. It's considered a hunting analytic, so mainly used for just running it and identifying what is actually hitting on these. You can expand on these as much as you want. That's the beauty of this. You can add different eval statements and change it and modify or remove, play with it as much as you want. Same with the scores. We talked about the scores a little bit in our demo. You can modify and change these scores however you see fit. If there's something that just seems to be more high fidelity, change that score and just see how it reacts within your data that you have, which that's kind of the beauty of this. So yeah, like I mentioned in the demo, this analytic really just started with a bunch of keywords or, hey, show me just base 64. And then we ended up with something more like this. And that's kind of what led to Alex on Twitter, Alex Texeria. He had also done a lot of the same work. And so on the right-hand side, the way his stuff works is pretty similar. He's building it based on qualifiers and using the same matching or eval statements that we're using. Mine's just a little bit more simpler because mainly I just want to hunt through this data. I want to find, keywords that are matching or hitting on things within it. His was more focused and is more focused on things to alert on and scoring things and finding like risky assets. So both are extremely powerful. I highly recommend that you check out Alex's work. It's excellent. The link to the blog is on the bottom, and our YAML as well is here too. And so one thing you can do with this, and any analyst can go and perform, is, as I mentioned in the demo, when you run this, you'll be able to see all these little stats numbers everywhere and a score on the far right. In particular, you can save this as a dashboard, and that's all I did here is I just saved it, and it just allows me to go back, rerun it every X amount of days or whatever I want to do with it. But I do like just that heat map overlay so that I can say and see something new or different. And then as discussed in our demo, you can flip that score, look at the inverse. You don't want to always look at the highest scores. Maybe there's something down there at the bottom that didn't trigger on any of these, which will help us modify our analytic to have new values that might be of interest to us, or tune out any other false positives that might need to be tuned. I also want to call out Hurricane Labs. They wrote an excellent TA and a blog, and we did borrow the script, and we added on to the script that they had provided as well. But their TA does provide some parsing for module and transaction logging plus the script block. But it's all here. The TA is freely available, and then their blog is linked on there as well, so you can further read on their script block logging as well. And then with that, our analytics, we produced about 16 analytics for PowerShell 4104. The team is consistently and constantly adding new things because we find there's a lot of value in looking at 4104 event data. It's just that raw PowerShell. There's no longer the base 64 encoded command, but now we can take it and begin to dig deeper just looking up those keywords. So we wrote about 16 initially, and then as we speak, there's more being written by our team today, which is great. You can actually search on our repository under security content, just search 4104, and that'll come up with all the 4104 event code analytics that we've written so far. Additional resources, definitely continue your journey. There's a lot here. So definitely check out our security content repo on GitHub. Read and review the blog with all of our detections, and that's where we'll have more things broken out. Hit us up. We are in Slack. We have our Splunk user groups and a security research channel there. And then we also have our Splunk Threat Research Team page on the main website as well. Here at the bottom, Cybersecurity Threat Research. And yeah, continue the conversation with us at community.splunk.com. You can sign up or sign into our community site. We have lots of things. We're under the tag Splunk ES Content Update, where you can share any other ideas. Again, you can reach us on Slack, Splunk Tech Talk section for security, and any other ideas, search, vote, and request enhancements to solutions. Well, thank you so much for joining. I really appreciate it. Thank you.